Okay, welcome to the fourth component of the Cubics and Quartics revision. This is questions from the short answer section of a revision sheet that I handed out in my class. So those who weren't there might find a bit of benefit from this. Firstly, sketch the graph of R mapping onto R of 2 bracket x plus 1 cubed plus 2. So we have no restriction at all in our range or domain with that section there. Any real number will do. That's good. Now, what we need to do is we're going to compare this to a graph of y is equal to x cubed. So a graph of y equals x cubed would look something like this, where we come up with point of inflection through there. Fix up that x a bit. And looking at the equation that we have, 2 out the front here is our dilation factor. It'll dilate it a factor of 2 from the x-axis. Inside the bracket we have a translation. This will shift it to the left by 1. And we have another translation here which will shift it in the positive direction of the y-axis by 2, or shift it up by 2. So we can take our graph of y equals x cubed, and it's going to go left by 1, and it's going to go up by 2. That gives us a starting point for our point of inflection. So I'll just draw another one here. So we're looking for the same shape as the y equals x cubed graph, except we're going to have our point of inflection across by 1 to the left and up by 2, which if I start the sketch it will go somewhere in here, like so. So we know that this point here is at -1 and 2. Oh, looks like I'm -1, 1. Do that again. -1 and 2. It's better. Now, to work out a couple of intercepts, we need a y-intercept there and we need an x-intercept there. So for the x-intercept, we'll make y equal to 0. That will give us 2 x plus 1 cubed plus 2 equals 0. Take away 2 from both sides, we have 2x plus 1 cubed equals -2. Divide both sides by 2, which gives us x plus 1 cubed is equal to -1. And then we can take the cube root of both sides, which will give us x plus 1 is equal to the cube root of -1, which is just -1. And then if and then we take away 1 from both sides, which will give us x is equal to -2. So that tells us that our x-intercept is at -2 over here. Similarly, for our y-intercept, we make x equal to 0. So we have y is equal to 2. X is 0, so it's going to be 0 plus 1 cubed plus 2, which will equal 2 by 0 plus 1 is 1, cubed plus 2. Order of operations, we do the power first, so 1 cubed is 1, times by 2 is 2, plus 2, which is equal to 4. So that tells us that our y-intercept equals 4. And that's that question answered. Okay, let's move on to the next one. State the transformations that transform y equals x cubed to the graph of y equals 3, bracket x take 1, cubed plus 2. So we've got our x cubed component. The transformations that we have is we've got the 3 at the front. So what the 3 at the front does is that's a dilation factor of 3 away from the x-axis. And then the other translations that we have is inside the bracket here. That's going to shift it to the right by 1, and this is going to shift it up by 2. So for the -1 bit, and this little section here doesn't actually need to go in, I'm just saying this is what those components do. So the -1, that's a translation away from excuse me, the y-axis, or in the positive direction, of the x-axis by 1 unit, and the +2 at the end here is going to be a translation in the positive direction of the y-axis. By 2 units. And that's that question. So we've got 1 dilation and 2 translations, and they are the transformations that happen in this particular case. Let's move on to the next question. If we have f of x is equal to 3x cubed plus 2x squared minus 19x plus 6, A, show that 3x minus 1 is a factor, B, factorise f of x, and C, sketch the graph of y is equal to f of x. And we don't need to worry about the coordinates of the turning point in this particular question. So firstly, looking at showing if 3x minus 1 is a factor, I'm going to set 3x minus 1 equal to 0. I'm going to rearrange this to work out what x is equal to, so we add 1 to both sides. 3x will be equal to 1, then we divide both sides by 3, which gives us x is equal to 1/3. So then what we need to do with that is we substitute that into this equation using the factor theorem or the remainder theorem. If we substitute x equals 1/3 into this question and it is a factor, then we should get a result of 0. So let's try it. If we've got, for part A, 3 by 1/3 cubed plus 2 by 1/3 squared, take away 19 by 1/3 plus 6, and go through this. This will be equal to 3. 1/3 cubed is 1 cubed, which is 1 over 3 cubed is 27, plus 2 by 1 squared is 1 over 3 squared is 9. Take away 19 by a third plus 6, which is equal to 3 over 27. 3 goes into 27 3 times, so that's going to be 1 over 9 plus 2 over 9. Take away 19 over 3 plus 6. So if we keep going with this, 1/9 plus 2/9 is 3/9. 5 plus 19 over 3, which is 6 1/3. 6 goes into 19 3 times, or 3 goes into 19 6 times with 1 remainder. 1 over third plus 6, and that wasn't a plus in the middle, that was a takeaway. That's where you can make silly little mistakes. 3 over 9 is equal to 1/3. So take away 6 over 6 1/3 plus 6. So the two components at either end there, 1/3 plus 6 is 6 1/3. Then we take away 6 1/3, which equals 0. So by getting an answer of 0 at the end there, that's told us that 3x minus 1 is a factor. The question was saying show that, so we need to say therefore shown to answer the question. Okay, so that's the first part of that question, and what I need to do is to make a little bit of room so that, oops, squish all that up there so I can do a bit more work in this question. So there we go, we've got that. Then for the second part of this question, I'll change it to a different colour. We like a little bit of blue. So what we now need to do is to factorise this particular function. So we've already found one factor, so we need to do a long division. So for part B, which I'll do it over on the right hand side here, I'm just drawing with my hand, my knuckle did that. So we need to do a long division. So 3x take 1 will go into 3x cubed plus 2x squared, take 19x plus 6. That goes into there, so 3x cubed divided by 3x leaves us with x squared. X squared times 3x is 3x cubed. X squared by -1 is negative x squared. Need to take that away. 3x cubed, take 3x cubed is 0. 2x squared, take away negative x squared is a plus, so that becomes a 3x squared. Bring down the 19. We can bring down the 6 now, whatever, it doesn't matter. So next we go 3x squared divided by the 3x at the front will leave us with x. Multiply that by what's out the front, so x times 3x is 3x squared. Every now and then this little pen goes a bit funny. Might need a new tip. And x times -1 is negative x. So then we take that away. 3x squared take away 3x squared is 0. Negative 19 x take away negative x, so that's a plus, so negative 19 plus x is negative 18x. And then we bring down the 6. Now we go negative 18x divided by the 3x out the front will give us negative 6. Multiply the negative 6 by what's at the front, so negative 6 times 3x is negative 18x. Negative 6 by negative 1 is positive 6. Take that away, we end up with 0. So therefore we have now got our function of x with our 3x take 1 linear factor at the front. And the second one here is x squared plus x take 6. And factors of negative 6 which add up to positive 1, we need to further factorise that second one, is x plus 3 and x take 2. And therefore we have factorised the question. And the third part of this is to sketch the graph. Don't you love graphs? No, I don't. Okay, they're not that scary. So we'll set up our axes. We will know that our x-intercepts we can get from the factorised form. For the first bracket here we're going to have an x-intercept of 1/3. Set that bracket equal to 0. Transpose it so that we end up with x is equal to 1/3. From the second bracket we'll end up with x is equal to negative 3. And from the third bracket we end up with x is equal to positive 2. So our intercepts that we'll have are at negative 3, positive 1/3, and positive 2. If we go back to the original question, up here plus 6, that's going to be our y-intercept. Y-intercept x is equal to 0. Every other component of that question's got a 0 in it, so they all cancel down, which leaves us with positive 6 as our y-intercept, which is going to be up here. And we don't need to worry about the coordinates of the turning points for this particular graph. So what that leaves us with now is we need to sketch the graph. It's positive x cubed, so we're going to start down here and come up like so, down like so. Almost got that 2 x-intercepts there. So let's see if we can do a little bit tricky work here. When we're sketching the graph, the accuracy is not essential, as long as it's pretty close. And what I've done here, it mightn't even hurt to actually sketch the graph and then put your intercepts in later, or label your intercepts just to get an idea of where they should be. Okay, so the little marks that I had there, I just got rid of them. And that's one advantage of working with pencil. If you work with pencil, you can rub stuff out. It's always good. Sometimes examiners don't like it, so work with pencil. As long as it's a nice dark pencil, it won't rub out easily and won't be too light when the examiner is trying to read your questions at 4 o'clock in the morning or 2 o'clock at night or something like that. You should get away with it, but you might need to check with your particular school how they like that. Okay, so that's that question there. I haven't labelled my y-intercept, which was 6. And I've got my 3 x-intercepts labelled as well, and I've scribbled the graph over where my y label is. That's alright. And that's the end of that question. Okay, hope you find that useful.